everyone, welcome to this presentation on the best practice for drawings in advanced steel. A little bit of introduction to start off with. My name is Alec Giles. I'm a structures consultant at Graitec UK. I was originally trained as a mechanical design engineer 30 years ago. I spent about 10 years doing design. Then I moved sideways into the CAD manager position. And I've been doing CAD consultancy and training for around 20 years now. And the last 10 years of that, I focused 100% on advanced steel at Graitec. Why should you choose Graitec as your business partner? Well, Graitec are unique in being able to offer services and products that cover the entire life cycle of your product within your company. And we split that into 4 areas. First of all, we have Graitec Create, which you use Autodesk software and products to design your products, and we enhance all of those with the Graitec Power Packs. If you're not familiar with the Graitec Power Packs, we have a bunch of tools, a set of tools that add extra bells and whistles, extra functionality and useful efficiency and improving tools into various packages. We've got Power Packs for Inventor, for Revit, and for Advanced Steel. There's in the handout section on your GoToWebinar sidebar there, then you have a handout telling you what sort of features are in the Power Pack for Advanced Steel. Once you've designed your product, you need to check it's going to actually work in the real world, so you can use the Graitec Simulate, where we have market-leading, state-of-the-art technology on the simulation and analysis programs, which can help you to analyze your products and make sure that it's suitable for purpose. Then, of course, once you've satisfied with your design overall, you need to move into manufacturing it, which is Graitec Fabricate. And we have tools and services there that can help you manage your entire workshop, whether it's human welders or it's CNC machinery. It can do all the scheduling for you, it can do all the programming of the CNC machines for you, and control all of that workflow for you. And finally, all of these things create massive amounts of data, loads and loads of different files flying around. So we have Graitec Manage that can help you control all of your work in progress data within your company, protecting your IP, managing it, make sure everything's controlled and up to date, everything that you need until it goes outside your company into a third-party data environment. So Graitec can help you throughout your entire business process. This webinar is one of many that Graitec do, many of which are based on Advanced Steel. So if you haven't already tried it or seen it, you can go to the Advanced Steel content portal using the link here. Again, download the handout and the links will be live in that handout PDF. And this lists all the previous webinars that Graitec have done, based for Advanced Steel, and many different subjects covered, and you can watch a recording of any of those webinars at your convenience. As well as webinars, we are constantly posting blog posts with hints and tips and tricks and ideas for how to get more out of your Advanced Steel, how to do things, frequently asked questions. A lot of support calls are actually already answered on our blog. So check out our blog, follow the link here to subscribe, and you'll get notified of any new blogs, but also look through the many blogs that are already there, and you'll find lots of useful information. The 2 I'm doing today are the last 2 webinars in this particular series scheduled right now. We'll have many more coming up very soon, so check out the future events page following that link, and you'll be able to sign up for any ones that are coming up imminently. A really big event coming up in June is the Graitec BIM Up Global Digital Conference. As you can see from the banner there, we're expecting to have over 200 classes and presentations across those 3 days. You can register for it right now. Registration is open. Click the link to do so. It's completely free, so you've got nothing to lose whatsoever. You don't have to be watching solidly for 3 full days. You can simply dip in and out to the classes you're interested in and watch those. And if you don't watch something, you're going to be missing out. There's going to be masses of useful information presented during those 3 days. So keep your eyes open and follow up that, sign up for that right away. So now to the subject at hand, drawings in Advanced Steel, and what's the best practice for getting the best drawings out of it? Well, we're going to explain how to make drawings in very simple processes, but really a lot of people get drawings, they're self-taught and they can get something out, but they're not really getting the best. So by doing things in the right way, using some best practices, we can get the best possible automatic drawings. So I'm going to discuss and mention things like, should you use cameras or should you use the drawing styles palette to create your GA drawings? If you're using cameras, what do all those properties mean and how to get the best out of them? I've got one little note about drawing numbers, how you can keep those in sequence and make sure things don't go haywire. What's the main part all about and how does that affect assembly drawings? Very, very important. And then also we'll discuss model roles and how they influence things. And I've got some comments at the end about how to use the best paper size. So these are some things we're going to look at, and if you combine all these together, I think you'll get much better drawings and much less editing required. So first one of those was, should you use cameras or should you use the drawing styles palette? If you use a camera, you want to create a camera, first of all you have to create one for each view you want. That means you have to set the UCS, you have to use the create camera command, you have to fill in the camera properties such as scale, view limits and the style. And then once you've done all your cameras, you generate them using a drawing process. If you chose to use the drawing styles palette, then for every single view, you have to set the UCS, you have to select the style you want from the palette, you have to either accept the default settings or modify settings. And if you're modifying the settings, there's lots of things you have to set. The prototype you want to use, the scale of the view, the file name, the view limits, and others. And you have to repeat that for every view. So as you can see, probably it's about the same number of clicks, give or take one or two, same amount of work, same amount of clicks, whichever method you choose to use. So what's the pros and cons of each method? Well, here's a quick table to summarize this. So if you use the drawing styles palette, there's nothing in your model that shows where that style came from. There's nothing that will allow you to see what it's related to. But with the camera, you get a physical object in the model representing where that camera is showing. And because you've got that physical object, if you want to adjust it, you can use grips or you can edit the properties of that object to change the size of that view. If you didn't quite include enough or included too much, you can shrink it down. But if it's a view created from the drawing styles palette, all you can do is edit that view within the drawing, and you can edit the overall limits of that view, the X and Y direction, but you can't really do anything else. And that'll only be ever about the center of the view. Which brings me to the next one. With the camera, if the center's in the wrong place, so you're getting things you don't want on one edge, you can actually physically move that camera object using the move command. You can't change the center of a view if you use the drawing styles palette. So you'd have to delete the view and start again. If you've got lots of similar views, you might have sections on grid lines through the building, or you might have different floor plans for different floors of the building. With a camera, you can very quickly and easily copy that camera along the building or up the different floors and just simply change the name as you go. Whereas with the drawing styles palette, you have to do the full procedure every single view. There's no way to simplify or automate that. With the scales, using a drawing style, you have to calculate yourself. You have to know how big the view is going to be or how big the model is, how big the bit of paper is, and then do some maths to work out the best scale. But if you're using a camera, you can let the drawing process calculate or choose the best scale for you. So that saves you having to mess about with that. You have no control over the title of the view if you're using a drawing style. It's just going to be called whatever the view style wants to call it. But with the camera, the description part of the camera properties is used in the drawing title. So you have more control. To access the drawing itself, if you've used drawing styles, you have to open the document manager, search up and down the list of drawings and find the right one and use the open drawing command to get to that drawing. But if you're using a camera, you can jump straight to that drawing by right-clicking on any object that's shown in the view or on the camera object itself, and you'll be able to jump to the drawing of that part. I'll show you that. Here's a model. If I want to see the GA view of that rafter, select the rafter, right-click, and like I've got show part detail and show assembly detail, if I've used cameras, I also have show camera detail. And you can see it actually appears on two different drawing sheets. So I can just click on 101 and it opens that drawing directly. Bingo, there you go, straight into the drawing. I haven't got to go through Document Manager. I know a lot of people complain about how slow Document Manager is, having to open it and search through the list every time. This bypasses all of that. The drawing file name. If you're using the Drawing Styles palette, you have to manually assign that drawing file name if you want anything other than the really basic format. But with cameras, because they're drawn using a drawing process, you can have formulas for the file name and you can have intelligent file names formatted how you like that automatically increment. Should you decide you don't like the style you used, if you did the drawing styles palette, there's nothing you can do about it. You just got to delete the view and start all over again from scratch. But if you use the camera, it is possible to change the style selected inside the camera. You still have to delete the view, but all you have to do is regenerate it. You don't have to set all the other properties again. The view limits, the scales, the descriptions and so on are all still remembered. And all you have to do is change one property and hit regenerate. And lastly, you can link a camera to a model view if you wanted to, rather than having to, you can't do that with the drawing style from the palette. So again, I'll quickly show you that. If I open Project Explorer, I don't have any model views at the moment, so I could create a new model view, add a grid line. Let's choose grid line B, and I'll give it a name, grid B. I'll choose that arrow there. Okay, so I've got my model view, and I can see that's just what I want. If that's what I wanted on my drawing, I don't have to set up a separate camera. I can go to that properties of that view. I can go to the camera properties page and say create an automatic drawing, and that now behaves like any other camera in terms of being able to create that. So you can not only have the camera, if I show you the physical representation of the cameras, I've turned them off in my model at the moment. Turn that layer back on. Those are my cameras. But with the model view, I don't just have the representation, I can also click the light bulb to isolate what I might see on that drawing view. That's a nice tool. So combining all those things together, I think it's quite clear for you to see that I would recommend strongly that you use cameras to create all your GAs instead of using drawing styles directly. So if we're going to use a camera, we need to understand the properties within the camera. And let's have a quick look at some of what they are. So the first property is type at the top here. What's that all about? Well, those are intended for grouping related views onto a set of sheets. So for example, if you're doing your foundation drawings, you might have a couple of overall foundation layouts. They might use stanchion layout all, for example, as a style. And then you have a couple of base plate details using base detail UCS, so different drawing styles, but they all want to be on the same sheet. You want different views on the same sheet. So you can call them all the same type, anchor plan, and the process will automatically collect them all onto the same sheet into as few sheets as possible. And when you go to a different type, it can start a new sheet. Unfortunately, there's no safeguard to stop the system producing duplicate camera views. So you want to define as many camera views as you can possibly think of first, and then run your drawing processes. Because after you've done those first processes, if I go back again and say cameras overview or cameras anchor plan, I don't just add my one new base plate, I would redraw all the first anchor plans and foundation plans and everything again, which is a bit annoying. So after the first pass, you kind of have to use cameras selected, but it's still a useful tool. The description box, a lot of people seem to leave that blank, but the description is actually going to form part of the title of the view. So depending on your drawing style, it might be the entire title of the view is whatever you type in the description box. So I might say mezzanine floor plan, or in this case, my style says floor plan hot rolled, so it's going to have the word hot rolled floor plan on, and I just need to put in mezzanine. The rest of the title comes free, so it depends what style it is. You can experiment on your own, but you have some control now of what the unique title of that view is. Then underneath that, you have the drawing style. Now this is absolutely critical to the cameras. Depends on which build you're using. If you're using other builds, it might be different, but in the UK build, if you leave that as a dash, which is how it starts, you simply won't get a drawing view at all. In most of the other builds, if you leave it as a dash, then it selects a default style based on the type. But as we've already said, with a type, you could mix up different styles to go on the same sheet. So with this style here, you can choose what style you want for your view. And in the UK, it's absolutely critical that you choose what style it is. You can't leave it as a dash in the UK. So don't get confused with the title of the view either, or the style. The style might say 3D view all, or it might say floor plan hot rolled. But if you like what that gives you on an end view, use it for an end view. If I want to use a plan view, but I use a 3D view style, I can use that. This name of the style is just what the person creating the rules had in mind. But if you like the result, you can use any style in any direction. The scale. Now this is an interesting one, because as I said on the last slide, if you want to, you can leave this as a dash. If you leave this as a dash, then the drawing process will go through a list of scales that's been predefined, probably in the UK's terms, 1 to 25, 1 to 50, 1 to 100, 1 to 200, and so on, to try and find the best fit on the sheet. So you don't have to do any maths, you don't have to know how big your building is, you don't have to know how big the sheet of paper is. The system's going to choose a scale that fits for you. But if 1 to 25 is too small, or the default scale is too small, and you want a bigger one for the enlarged base plate or something, you can select something like 1 to 10 or 1 to 5 in that list, and it will lock that view to the selected scale. The second page in the camera properties is the detail box page, and you've got Z depth and you've got X and Y directions, and it's important to understand these as well. So for the Z depth, if you want to show the entire model, you don't need to do an enormous camera. You can leave the Z depth front and rear unticked, and you can leave X and Y on automatic. And the camera object will be a small symbol like shown here, but that small symbol just has one little bit of graph paper and an arrow pointing at it. That will show the entire model because it's infinite in every direction. There's no need to do a 500-meter camera. But if you're doing floor plans or sections on grid lines or anything else, you're going to want to limit the front and back of that view. So you're going to tick front and rear and set the depths as you want. And as you set the depths, you will see extra planes appear on your symbol. And these planes show the limits. So only what's between those two planes will show on the drawing. But notice there's no vertical edges, so they're still infinite in the X and Y direction. So again, you don't have to have an enormous camera to show the whole floor, just set the front and rear. But then sometimes you do want a small close-up of certain areas, so like a base plate detail or a single joint. So if you're going to limit the X and Y direction, then the camera gets vertical edges on it as well, as soon as you change X and Y from automatic to something else. So these vertical edges are telling you now this camera is literally restricted to exactly what's inside that box. So that camera has to be stretched and pulled. You can see the size of it. You can use grips to change it if you don't like playing with the numbers, until you get the right size to enclose whatever you want to see. So if you have a look at my model, you can see here I've got 4 cameras down here, and they're all going to show the entire model. But then I've got this one which has got vertical edges on, so that's just showing the base plate in that area. For the mezzanine floor, it's a bit bigger, but I don't want to see the whole model, so I do have to have a big camera for that. But I don't have to have lots and lots of huge cameras obliterating my entire model. And that's hinted at the last point on the slide here. If your X and Y is set to automatic, because you want to show the whole model, you don't actually have to worry about where you put the camera in the X and Y direction, because it will show the whole model regardless. So rather than put everything at the bottom of the column and embed it in the column, you can't see it easily, I like to put a lot of these cameras out in free space. So again, looking at my drawing, you can see my overview cameras that are going to do the whole model. I've put them on this free grid point here, so they're easy to see. I can spot them later, I can edit them easily. And again, this one here is my overall foundation. Doesn't matter where it goes in the X and Y direction, only in the Z direction because I'm limiting the depth. But I can see it easily. It's not hidden inside a column or inside another shaded object. A quick comment about the drawing numbering. This will vary depending on how you operate and where you are in the world. So I know different areas use different systems, but nevertheless, I think it's going to be good for everybody. Based on the UK numbering, if I make a mix and match of doing GA drawings, assembly drawings, and part drawings, maybe I'll do a few GAs, a few assemblies, then another couple of GAs, and another few parts, and another couple of GAs. You can see in my list here on the left, I've got missing numbers. Numbers 104, 105 are missing, 111, 112, and so on are missing. So if I printed all of those off, people are going to come to me, where's all the missing ones? You haven't given me the full set. But I have given them the full set. It's because these other numbers, although these parts and assemblies use our part numbers on the UK build instead of drawing numbers, they still reserve an internal drawing number. So number 104, 105 will be one of these other drawings, even though I can't see that number. I have given the full set. This can be confusing and a bit annoying. So there is a default in the system. If you go to the defaults in management tools and under drawing general, the default is called drawing numbering behavior, which doesn't give you much to work on, and the tooltip isn't much help either. But actually, if you tick that option, then all your assemblies and parts the drawing numbers for those will move up to a 1000. 1000 upwards. So when you do your GAs, no matter how many drawings or parts you've done in the meantime, they have the number 10 next to consecutive 100 number isn't taken. So you can see this time all my GA numbers run in sequence from 100 to 110. There's no gaps in the numbering, no confusion anywhere, because these numbers internally would be 1000, 1001, and so on. So I think that's a bit of a no-brainer. Unless you've got more than 900 GA drawings, which I can't imagine you would ever have, then you're never going to have a gap in your GA drawing numbers. I think that's a good idea to do, but that default is not the most obvious default going. Moving on to assembly drawings, this is probably where a lot of the controversy arises. One of the important things about an assembly drawing is the main part. It's really important to be aware of it, consider it. What is the main part? Well, a main part, every single assembly has one part in that assembly that's identified as being the most important part of that assembly, and that is what we call the main part. The main part dictates everything about what happens in the assembly drawing. That chooses which drawing style is chosen and which orientation everything is drawn on, and everything else about the drawing. The main part, by default, is drawn horizontal. There's a handful of drawing styles where it might be based on the UCS, or you could have used the assembly detailing direction to override it and draw it in a different angle. But unless you've done that, it's going to be drawn horizontal. I'll show you in a second. If you've got the wrong main part, then your drawing might exist, but it's not going to be very good. Here's an example at the top here. I can show you on my model in a second. It's called PL2. It's what PL is plate. And yeah, that's clearly a column. In the UK, we don't expect columns to be drawn vertical. We expect them to be drawn horizontal. Saves a lot of paper space. So why is that drawn vertical? Why has it got the wrong prefix? It's because it's got the wrong main part. If I change the main part to the correct one, the beam, instead of the plate, using the command output part marks create main part of assembly, then I get this drawing instead at the bottom. It's now called column 5, and the beam is laying down correctly, and I get the correct drawing. Let's see if I can quickly show you those. So if I look at the drawing, I've already got the drawings of these. Show assembly detail. There you go, PL2, drawn vertical. It's on an A2 sheet. It's not what I want. It's a drawing, but it's not the best drawing. So what I'll do, very quickly, I'll go to Document Manager. And I'll find PL1 and PL2. I don't want those. I'll delete them. Okay. Right. Now I can guess it's the wrong main part, but we can use this command here. Mark main part of assembly. Choose the assembly, and it's showing in blue the main part. So yeah, the base plate's the main part, not the post. When it numbers automatically, the heaviest part of your assembly is the one that becomes the main part. So in this little spindly column, the base plate is quite big. The base plate's a couple of 100 grams heavier than the column. So we've got the wrong main part. So I'm going to change the main part. It's done one. Here we go, create main part of assembly. Click on the other. I want that to be the main part of that assembly. Shows it's cleared the assembly number. So now I've got the correct main parts. I renumber. So it assigns them correct numbers now. And I do my drawings. So I've already got all those, I know that. Have a quick look. Show the assembly detail this time. And there you go, it's now called C5. It's laying down on an A3 sheet, not an A2 sheet. So that's a lot better. Much neater, clearer drawing. So getting the main part correct is going to be very helpful. Like I say, unless you tell it otherwise, the main part's always drawn horizontal. So with these assemblies, or this railing or the stair, quickly have a look at the drawing there. The main part is the handrail, and that's been drawn horizontal. That might be great. You might like that. A lot of people do like that. that's fine. But a lot of people aren't so keen on that. They want the handrail drawn going uphill or the stair drawn going uphill. So once again, I'll go to Document Manager. And I'll find railing and stringer. Delete those. I'm deleting them because when I change the direction, it's probably going to want to choose a different scale and different sheet size. So I'll set my UCS how I want it. So I'll rotate on Z, and I'll rotate on X. So I'm going to look at them both from this side, the right, with them going uphill in situ. I use Define Assembly Detailing Direction. Pick any part from the assemblies. And then again, replace my lost drawings. I'm using an all assemblies process, so I don't have to keep selecting the assemblies. It'll just find the ones that have drawings missing and do them. Much easier than to try and keep selecting the assembly everywhere. And now if I go to the detail of that railing, that's now drawn going uphill in situ. So you might prefer that option. So the main part influences what style is chosen. It influences which direction it's drawn in and what part number it gets, but that's less important. So the main part is something you definitely should be aware of and can be a cause of problems. Oh yes, next topic, model roles. What was that again? Ah, model roles, yeah. Just remind me. Model roles. Are we getting a hint yet? Model roles. They are important. The wrong model roles is the biggest cause of poor drawings out of anything possible in the system. Nothing makes a bigger difference to how your drawing comes out than selecting the correct model roles for everything. People who are self-taught are never going to know the right model roles to use. The correct model role for a certain object depends on which build you're using, whether you're using UK, America, Australia, or something else. But you need to choose the correct one. Any part that's created by a macro or a joint, such as a stair or the railing or haunch joint or end plate joint, or whatever, will have the correct model roles assigned automatically by the joint. And you shouldn't really ever change those, because any drawing styles that are set up in the system are expecting to have the model roles that are automatically set up in the system as well. So if you mess about with them, you often can't, but even if you can, if you messed about with them, you're going to just make things worse, not better. But if you've modeled something manually yourself, it's absolutely critical that you set the correct model roles if you want to get the best drawings. There are no excuses, no whinging or complaining. It has to be done. It's not that big a task, but it must be done, and it will save you much more time in the drawing editing than it costs you to actually do the job. If you've been trained by Graitec UK, when you do your advanced steel training, we'll give you tables of the acceptable model roles to use. There's probably twice as many roles in the system that are actually ever used. And choosing the wrong role is as bad as not choosing a role at all. If you haven't been trained by us, or you haven't got a table of the acceptable model roles, then the only way you can find out what the right model roles are is to reverse engineer the drawing styles. And anyone who's ever looked at the drawing styles will know they blow your mind most of the time. So to reverse engineer them is going to take quite a lot of knowledge and understanding to see which ones are useful. So don't try and be trained on your own or self-taught. One of the benefits of having proper training is that we can tell you this sort of information. If you use the wrong model roles, as I've already said, it's as bad as not using any model role at all. Lots of people try to get away with just calling everything beam or everything plate. If you do that, yeah, you'll get a drawing, but you'll only get the most boring generic drawing for everything under the sun. And a rafter is drawn with different rules to a railing, which is drawn with different rules to stairs, which is different rules to concrete beams or a base plate. It's no good just using the same role for everything, so you'll get the same drawing for everything, not the right rules for the right task. So here's some examples. Here's a drawing. This is a box frame made up of 15 pieces of RHS, a couple of bits of plate. It's not an awful drawing. You can probably work out what that is. Those end views or section views, they're not too obvious, but you can probably figure things out. That's currently called beam. And that's what you get, because everyone just calls everything beam. But if you actually change that from beam and called it frame, what am I saying? Called it frame, then you're going to get this drawing instead in the UK. This drawing always has front view, top view, and two end views. And in this case, the edge of every beam and edge of every plate is dimensioned for you, and they're all labeled correctly. If you prefer system lines, there's an option to do that instead of the edges. So simply changing from beam to frame, you get this drawing. Much easier to understand and much more consistent. Here's another drawing. This is a simple bit of tubular roof bracing with a tube with an end plate and tab plates either end. It's not awful again. You can probably figure out what it is. Are those tab plates in the middle where we've got those sections? Looks like they're in the middle, but they're not dimensioned properly. Not the end of the world, but can we do better? Again, that's just called beam at the moment. But if you change that to be called roof bracing for the model roll, you get this drawing. You haven't changed anything else in the model, just the model roll. But now you get a completely different drawing. The most important dimension on that roof bracing is that 6325, the hole centers. If they're right, it doesn't really matter if the plates are a millimeter out or 2, as long as the holes are in the right place. And you've got the top view there showing that those tab plates are indeed central. One last example, here's a rafter. Again, I've called it beam. I've deliberately set every model roll wrong in this part, and not just the main part. So I've got loads of views there. How can I have 4 end views when I've only got 2 ends? That doesn't make much sense. And I've got top and bottom views there, really hard to understand. Notice the gusset plates here are not dimensioned at all. It's on an A2 sheet. It's 120, I think. Can't quite read that. It's not great. But if I change all the model rolls, I have nothing in the model, just the model rolls, I'll get this drawing instead. I've got a lot less views. I've only got the 2 end views. Top and bottom view weren't helpful anyway. It's now on an A3 sheet, but even though it's on a half the size sheet, it's much clearer and easier to read. And notice the gusset plates are fully dimensioned correctly. So this is the kind of difference model rolls can make. You must work out or find out the correct model rolls to use, and you must use them effectively. And like I say, if it's anything like the UK system, then there's probably twice as many rolls in that list as are actually ever used. So choosing the wrong ones are as bad as choosing nothing. You need to try and find out the right model rolls somehow. So nothing will make a bigger difference to how your drawings come out or getting the best dimensioning on your drawing. One last little topic to think about is the paper size. I'm often told by clients, oh, I do all my drawings on A3. I've only got an A3 printer. But if you think about it, how are you going to draw a 15 feet length of railing with pickets and fittings and all sorts on an A3 sheet and expect it to be a clear drawing or another complicated part? So I suggest insisting everything is on an A3 sheet is not very good logic. Remember, if you ever tried it, drawing on the drawing board, didn't matter what sheet size you were using, you always had to do your text 3 mil or 3.5 mil, and your arrowheads 2.5 or 3 mil or whatever it was. They would always be the same no matter what sheet size you're using. So if you use half the size sheet, you've got to use or scale the view down to half the size, but you've got the same information required, the same number of dimensions required, and the same height, text, and arrowheads required, but you've got to cram it all in half the space. So how's that ever going to be clearer? So you've got less room for the same amount of data if you're using a smaller sheet. These rules were set up when you had to print everything 1-to-1. And if you tried to print, we had pen plotters and things in the old days. If you tried to print an A2 or an A1 sheet on an A3 piece of paper, the pen plotters were too thick and you couldn't read anything, it just smudged. But with modern printers, you can print an A2, probably an A1, or maybe even an A0 sheet on an A3 printer using scale to fit, and it'll probably still be perfectly legible. So just because you've only got an A3 printer doesn't mean you can't use a bigger sheet size. All our drawings always say, do not scale. So what's the problem with printing it at a smaller sheet size, as long as it's clearly legible? So I suggest you try and look for a drawing process for assemblies or parts that has a range of paper sizes. So the top one in the UK is all assemblies, A3 to A1 single BOM, and that will choose a sheet size between A3 and A1 for you. The system always starts on the smallest possible sheet size. So just because you let it do it, you're not going to suddenly have all your assemblies on A1 sheets. There's still going to be 99% of them on A3 sheets, but a few complicated ones with a lot of information will go up to A2. I can't remember the last time I saw an A1. So here's a quick example. Here's another rafter drawing. All those views and information are necessary, but I've had to fiddle it. It's 1 to 33 and a third, which is in the standard scale, and I've had to cram those views in and rearrange the views just to cram them onto that A3 sheet. It's not very tidy, not very neat, but if I let that use an A2 sheet, it's got a lot more breathing space, got the same number of dimensions, the text size is exactly the same. It's at 1 to 20 now on an A2 sheet, much clearer and easier to read, much nicer layout, and you can still shrink it down. I can still read that on the screen. The screen hasn't changed size, so the text has been scaled down. So let's have a quick review then. Some best practices for getting better drawings automatically. First of all, should you use cameras or should you use the drawing styles palette to create your GA views? I highly recommend you use cameras because you've got much more control and something traceable and editable afterwards. We discussed each of the camera properties and how they can be influencing the result and hopefully get the best out of the camera. There is that default drawing numbering behavior. You want to tick that so that your GA drawings always stay in sequence. Make sure you have the correct main part. If you get a drawing that just looks, that wasn't what I expected, let's check the prefix as well, because if the prefix is wrong, it's almost a dead giveaway that you've got the wrong main part. So make sure that you got the correct main part. If you see a drawing that's weird, you've probably got the wrong main part. Delete the drawing, do what I did, change the main part to the correct one and recreate the drawing. Model roles. I'll say it again, there's no excuses for not setting the model roles correctly. If you leave those out and just skip that step, it might take you 5 or 10 minutes on a largish model, but it will save you hours on the editing time, so it's well worth it. If you leave it out, you've only got yourself to blame. If anyone in the UK gives us drawings saying our drawings are really bad, we always check the model roles, and if the model roles are wrong, we just simply say go off and do them again, and then just come back. There's no point in us looking at anything else until your model roles are right. And using the best paper size. Or you might have small printers and you might not want to use great big sheets. You might have a standard, but cramming everything onto a tiny sheet is not the best way to make a clear drawing. I suggest you're better off for letting the system choose its paper size and then still printing it on the smaller sheet. I reckon it'll be more legible and clearer if you use the fit to paper to scale it down. So hopefully that has been interesting for you and useful. All these things we've talked about are things we can discuss in training when we do it, but also they can be set up and customized. If you still can't get drawings you like, pretty much everything about the system can be adjusted. The drawing styles especially can be adjusted and tweaked, the drawing processing things. So we can change the rules to create drawings more like what you want. There are technical limitations, but if you're doing everything we've already discussed today and you still think, I'm always having to put this extra dimension on, or I'm always changing this to that, I'm always labeling something differently, then talk to Graitec, and steps 2, 3, and 4 here would include things like editing your drawing styles, editing your drawing processes, adding extra sizes of bolts or whatever it might be to the system for you. Doing your training with basic training with advanced steel is really only the first step in getting the best out of advanced steel. You don't know everything. It's like passing your driving test. You can just about drive safely. You're safe to be let loose on the road, but you're not going to win any Formula 1 races anytime soon. So it's the same here. If you've got your first step, you've had some training, well, okay, you can use advanced steel, but you're not getting the best out of the system unless you consider these other steps. Let Graitec help you. The investment, you will have to be a consultancy, but the investment you spend on that consultancy will be paid back many times in the more efficient work and more efficient drawings that you create in future. So we've got a few minutes for some questions if you have any. You can have a look in the go to a meeting interface at the side. Let's have a look, see if I can find any questions here. Just type in your questions in that interface if you've got any. Make sure you download 2 handouts. You need to have the handout of these slides so you can remember what we discussed, and you can click the links to get the links to other webinars and blogs, and the other one about the Power Pack. If you haven't got the Power Pack, that is provided to all Graitec subscribers without charge as a reward for being our customer. Okay, looks like we've got a question. Somebody had their hand up just then. I didn't find you quick enough. If you want to put your hand up again if you've still got a question, but like I say, the power pack is without cost to any Graitec subscribers. If you're not a Graitec customer already, then contact your nearest Graitec office and talk to them about it, and we'll see what we can do for you. Okay, there doesn't seem to be any questions coming in, so I hope everybody found that enjoyable and interesting, and thanks for your attention. Thanks very much. Bye-bye.